Good morning, everyone. Welcome to today's webinar sponsored by MidStates VRS in conjunction with Frontier Precision and Butler Machinery. We're going to talk about an introduction to the MidStates VRS, and hopefully by the end of the next 30-45 minutes, hopefully it won't take longer than that. I think we're going to cap it at 45 minutes. You should have some information, good information on what VRS is all about, what the MidStates VRS is all about, and walk away with some good information on how that's progressing within the territories that you may be interested in. Okay, so before we get started, what I'll do is just a slight little introduction and introduce the presenters today. So myself, my name is Steve Richter. I'm with Frontier Precision. I also have Mr. Alan Watazik. He is with Butler Machinery. He is the MidStates VRS Network Administrator. He's also on the call, so he'll do his best to keep me accurate and on the straight and narrow as we discuss the MidStates VRS. So if we look at the agenda for today, first of all, just to get everybody up to speed that is new to what a VRS is, we're going to talk about just a background on what a VRS is, how it works, how the MidStates VRS was brought into play, or what really happened, and the background of the MidStates VRS. We're also going to talk about the accuracy, coverage, and even just a little bit more information. So as we discuss today, we will also dive into the future of the MidStates VRS, and if there's any things that may be lingering out there that we're looking at, we'll talk about that as well. So here's just a little Wikipedia definition on what is VRS. So you can kind of read this statement, but basically a VRS is a virtual reference station system, basically a series of GNSS receivers, so they track typically GPS, GLONASS, and other satellite systems that are connected via the internet through a central server. The network stations provide a highly accurate corrected error model, which is essentially differential GPS or even RTK for centimeter-like accuracies. That error model is provided within the network to provide up to centimeter level precision to any GNSS receiver or machine that is working within the network. So again, it's a series of receivers that is connected via the internet to a server to provide corrections to people that are working within the network. So kind of a quick little what is VRS lesson there. If we look at it a little bit deeper and use maybe even a little bit of a graphic here, you can see what's going on in a VRS environment. As we mentioned, the data is transmitted from these reference stations, and I'm going to kind of point those out. You see these reference stations that are sitting out there in different locations. They're strategically placed. They are adjusted together amongst each other. They provide their positional error information back to the server. The server does basically what's called a least squares adjustment. It does an adjustment on the network in real time, all the time, 24/7. And then it rebroadcasts those corrections over a cellular or internet connection out to the people that want to use that correction. So in this case, you see a person standing there with a GPS receiver receiving corrections from the server. He's got a cellular device, whether it's a cellular data phone, MiFi device, some type of modem, to initially what happens, he broadcasts his position back to the server. The server looks at where he's at in the network, does a least squares adjustment in real time. It takes about 10 seconds. And then it rebroadcasts corrections to that particular receiver relative to the initial position that he started with. So in essence, there's no base station that the user is using. He simply walks out of the vehicle or turns on his machine, fires up, connects to a website, and the website starts streaming corrections to him. The corrections are based on where he starts his survey, so he has a virtual base station that exists at the location where he started the survey, started the machine, wherever it is. And you can see on this particular graphic, most major GPS GNSS receivers are supported. Trimble, Topcon, Leica, Ag Leader, Raven. There are others, that we just haven't listed, but most major GPS GNSS receivers are supported within a VRS environment. So if we dive into that even a little bit further and look at how VRS corrections differ from construction 900 megahertz radio or a survey UHF type of solution, or even an ag tower-based correction, you'll see that there are some limiting factors to those technologies. No radio range limitation or troubleshooting because you don't have a base radio when using VRS, so you don't have to worry about range. No setup, so there's no security concern of setting up your base station. There's also no baseline limitations. As long as you're working within the network, you don't have to worry about how far away you are from your reference station or your tower to make sure that you're receiving corrections within the precision parameters that you need to work in. So VRS is very convenient for that. And then obviously there's no base station setup required. If we look at the features of the MidStates VRS, there are 4 things that we have here that we're highlighting. The hardware that they've chosen to use within this VRS network is state-of-the-art. It's the latest Trimble NetR9 440 channel GNSS receiver. It's using Trimble Zephyr Geodetic 2 Model 2 antennas. The software is basically the industry standard, the Trimble Pivot software. Quite honestly, that software dating back to 2001 from the people who invented VRS. The physical reference stations are installed to the National Geodetic Survey Standard, or NGS standard, including some of the reference stations submitted to NGS, or the National Geodetic Survey, to be standard CORS receivers. And so some of you may be familiar with that. There are some receivers within the network that they've actually got CORS certification on. And then the software and support is provided by industry professionals with well over 25 years of combined experience. There's a lot of experience behind the VRS, the MidStates VRS, I should say, as well as state-of-the-art hardware, software, and installation. This is a picture of the standardized reference station cabinet. The MidStates VRS determined that it was important to be standardized across all of the installations for any troubleshooting, for any swapping out of failed hardware, whatever may happen. You can see here, there's a picture of the NetR9 GNSS receiver. There's a UPS backup. There's a cellular modem, so it's a VPN cellular network that the system is on. It's not reliant on different internet providers at different base installations. It's all on the same VPN. And you can see there's some other things about the secure cabinet. What I might do here is ask Alan to chime in on some of the specifics as the administrator of the network on the reference station installations. Alan?
Thank you, Steve. Yeah, so just to speak to the equipment a little bit, we chose the NEMA 4 enclosure with stainless steel hardware and a continuous hinge with a gasketed cover so that we can extend the life of this equipment as it is installed in the field. And on the next slide, we'll take a look at the antenna mounting And in the antenna mounting and hardware, we use all stainless steel components with an inline polyphaser, excuse me, as a lightning arrestor to protect the receiver from any direct hit to the Zephyr antenna. At the top you can see, well, you can't see very well, but at the top under the antenna we also have a Seiko leveling adapter that's used to level the antenna after the mount is attached to the building. All of our mounts have been chosen to be brick or concrete, and each of those brick or concrete mounted areas for the antenna have a footing below frost line for longevity of the face under the antenna. Steve?
All right, thanks, Alan. I guess I want to point out a couple things. It's important to note the reasoning behind the brick concrete mounts. First of all, NGS would require that if it was going to be certified as a core station with the National Geodetic Survey. And it's important for the integrity of the system. The system at the server is doing an integrity monitor all the time, and it's monitoring its own positioning of each reference station. And if you have a series of reference stations, or even a single reference station that has a lot of movement, the system is not going to provide as good of a precision when you dial in. So it's important that everything is very, very solid, and there's no movement or very little movement within the system to provide the best possible corrections in the field. A couple other advantages, we spoke to some already with this type of setup using the MidStates VRS, is it is a true network solution. You're not getting a radio baseline observation. You are getting a true network solution. When you dial into the VRS, as technical as it is, it actually does a correction from the 6 closest base stations to you, not one single reference station. So you are getting a true network solution. With that, there is no base station length limitation. So we can move around the network. Let's say, for instance, I'm doing a survey in eastern North Dakota within the MidStates VRS, and the next day I'm doing a survey in central North Dakota within the MidStates VRS. Those two surveys are under the same common coordinate system. They're not two separate coordinate systems. They would physically tie together. The same thing would be if I am going ahead and doing an ag survey, and I want to go from one field to the next, or I want water to flow from one field to the next, and I'm moving between towers. That doesn't take place here. You have a very consistent correction from the same series of network stations to provide the same correction throughout the entire system. And then obviously a couple of other things that we've noted before. No base station required. No radio is required to provide the corrections to you. And then obviously base station security is eliminated. One of the technical things that we just thought it was important that everyone knew about is the chosen reference frame for MidStates VRS. The chosen reference frame is the NAT83 2011 EPIC 2010 reference frame, which is essentially the same as the National Geodetic Survey provides right now. If you went ahead and did an OPUS, some of the people on the call would be familiar with this technique. But if you did an OPUS solution and you sent your raw GPS observables into OPUS to get corrected back from NGS, they would send that solution back in NAT83 2011. So we wanted to be consistent with that, and that is the reference frame that's being used by the system. The testing that has been done prior to turning the system on has all been done under that same reference frame. On the vertical is relative to GeoAid 2012. And as a lot of you know, if you go to a benchmark that is adjusted differently than GeoAid 2012, or maybe it was an older benchmark that you need to tie into, a calibration or a localization may be required to get onto that elevation adjustment. And that's easily done just like any other technique that has been done in the past using a single reference station. The procedure is no different. If we look at some of the applications that are available to users in the field for MidStates VRS, We broke it into two applications. There's an ag mapping application for planting section control, spraying section control, as well as autopilot on the ag side. If we look at it from a pure GIS mapping scenario, differential GPS mapping also would fall under that same application. The second application we call high precision. And high precision would give you obviously a much better precision horizontally and vertically, and that's the big difference between these two applications, and I'll explain that in just a moment. But the high precision application would be used for general surveying tasks, construction staking, things of that nature. And as a reminder, with a network solution, you're going to see repeatable pass-to-pass, year-to-year type of accuracy with either one of these applications. So if we break these into two, like I mentioned, and look at the ag mapping application, this is basically a sub-inch horizontal precision. So when you're using ag mapping, you can see currently there are 40 reference stations in coverage, and I'll kind of try to point out geographically what this may look like. This is actually a screenshot from the server of the reference stations that are in place today. And within the ag mapping application, sub-inch horizontal, but the vertical is not going to be very good. The vertical is going to be a foot maybe, or even worse. It's not designed to give real accurate vertical results. It is for a higher accuracy horizontal. It's certainly not a high precision application login. So if we look at the coverage map, this is actually Canada. This is in Canada, along north of North Dakota. This would be the North Dakota-Minnesota border. Here's Fargo. All the way down to, here's Sioux Falls, down to the tip of Iowa, down and around over to Pierre, South Dakota. So you can see eastern South Dakota would be right here. And then this is Interstate 94, if you draw a line from Fargo all the way to Montana. This is the coverage map today. So Montana, Canadian border, all the way along North Dakota, Minnesota, South Dakota border, eastern South Dakota, and wraps around. This little area here, even though you see baselines drawn here, would not be considered part of the network today. This little area, which would be southwest North Dakota, down into northwest South Dakota. That would not be considered part of the network today. If we take a look at the second application, high precision, you can see there's a big difference, and that is the number of reference stations. The reference stations are much closer together to provide that high precision accuracy anywhere in the network. Traditionally, most reference stations are no more than 75 kilometers apart to provide centimeter level precision, both horizontally and vertically. So both, all three, I should say, 3D type of application, you're going to receive centimeter level precision, just like if you set up an RTK base station. And again, very similar coverage, Canadian border, down and across the Minnesota, North Dakota, South Dakota border, south of Pierre, south of Sioux Falls, wrap around to Pierre, and then north. This would be Linton, North Dakota, for some of you that are familiar with your geography, and then around all the way to Montana. Again, this southwest, North Dakota, northwest, South Dakota is not part of the network. Okay. And one of the things, I'm sorry, I failed to mention, and I apologize for that. We want to try to capture all your questions. So we encourage you to put questions in the chat window. I should have said that at the beginning, because it's hard to answer questions as we go along, and we will do that at the end if we can. So make sure if you have questions, go to the GoToWebinar interface. There should be a question dialog that you can type in your question, and then hit enter, and we will do our best to answer those at the end, okay? So, so please ask questions. We want to make sure that we're answering all of them for you today as best we can. So you can see, I'm going to back up one. With the ag mapping coverage map, there are only 40 reference stations within that coverage. With the high precision, currently there are 96 reference stations being used. So 96, more than 2 times, to get that centimeter level precision both horizontally and vertically. I also thought it was important to give everybody an idea of what does VRS look like versus a traditional setup. So we just threw some things up here to give you some rough things to think about. If you look at a survey in a construction scenario, base station setup tear down depends on if you got to drive a long ways to your base, if you have different things that you have to worry about. Maybe some days the setup time is really easy because you're very close to the base station from your general work area, and sometimes you're farther away. So we just put in roughly 30 minutes a day, 15 minutes for setup, 15 minutes for tear down every day for a base station. Base stations cost between $17,000 and $25,000, and that includes the radio, the receiver, all the other ancillary equipment, tripods, tribracks, things of that nature. Maybe some service, extended warranties, things of that nature. So the costs vary on the base station here. So we just threw in a rough cost between $17,000 and $25,000 for a RTK base. Average lifespan 5 to 7 years. So we come up with a rough number of $3,000 plus per year to own a base station. On the ag mapping side, you know, the VRS is going to provide higher production section control efficiency. We don't have to worry about over or under applicating areas because of you can't get down the same pass year over year. So, so the application is much more consistent when using a VRS scenario. And we talked about the enhanced accuracy, or the accuracy of MidStates VRS would be much more enhanced over a RTX or OmniStar HP type of subscription service. So to look at a couple of things that we have to think about for traditional base setup, we just discussed a larger upfront cost. In the MidStates VRS scenario, there is no reference station to be set up, so there is no cost for a reference station. And in fact, many cases, we've seen users in other states take their base stations and convert them to rovers with a data collector to work with VRS. We talked about the setup and teardown. Just note you can't survey when you're setting up and tearing down, so there's no corrections for your machines or your rovers when you're doing your base station setup or teardown. Range limited to either line of sight with some radios like 900 megahertz. Other radios that are high powered, depending on the environment, can only give you 3 to 6 mile radius type of distance from the reference station. There's obviously no FCC user requirement, and this is kind of a big thing that we've seen. A lot of people on the call today have experienced the pain of going from 25 kilohertz to 12.5 kilohertz, which was extremely painful. And I will tell you, prior to that, or I should say, as that was being implemented, there's already discussion about going to 6.25 kilohertz. So I will just tell you, if you think it's great or it's okay with 12.5 kilohertz, it's going to get even harder. And keep in mind, today there are more satellite systems going up. There's more satellite data. We're tracking more satellites than we were 5 years ago. So trying to push all that data through a narrower and narrower band is going to be harder and harder. So FCC user requirements are going to get even more stringent as the years go on. and that range limited to 3 to 6 miles will become even shorter in some cases. If you're talking about a machine, there are radios that are permanently attached to equipment, so that's an extra cost and maintenance. And then obviously we talked about base station security setup concerns, whether it's a high risk environment of being stolen, turned off, moved. We've heard hundreds of stories about equipment being moved, turned off, thrown in the ditch, stolen. So that's all reference stations, because typically you set up your reference station and you walk away and you go ahead and do your survey, and a lot of times you don't see the reference station. So security can be a concern in some areas. MidStates VRS is subscription based, but some of the other things that you need to keep in mind: there's no line of sight required, only cell coverage. There's no setup for a base station, so you power up your machine or your rover and you go to work. I mentioned moving freely around the network without having to change towers. So in some applications, like an egg tower application, you don't have to switch from one tower to the next as you move from field to field. Same with the traditional base setup. You don't have to go from one base, move it, leapfrog it, do whatever you have to do to complete your survey. You can move freely within the network. And also keep in mind the cell modem connection that you have in the field can provide you with other services, whether it's data transfer from the field, fleet tracking, remote support, so technical support from the field, email, other things. The subscription, the way it is set up, can be moved between rovers and machines. So it is a subscription per piece of equipment. So you have one login and you can log in with one user, but that particular login can be used, turned off on one machine, moved to another, and log back in on the other machine. We know that it works with most GNSS manufacturers. You do have the flexibility to work in larger project areas because you're not limited by base radio range. And we discussed the leading edge technology of the system earlier. So if we look at the future, we're already talking about the future in an introduction webinar, but it is something that needs to be discussed, I think, because really, I'll be honest, this is to just better the community. That's what this is all about. If you're familiar with using VRS in other areas, it definitely improves the community. It definitely improves how you do your surveys and makes things a bit easier. So if we look at the future, you saw that we don't cover currently southwestern North Dakota, northwestern South Dakota. So larger coverage footprint is always on the horizon. Alan talked briefly about the reference station lifespan. So using a very secure cabinet and looking at other things like lightning arresters, things like that, so that we can prolong the lifespan of the reference station. And then other services like we just discussed, connecting to the Trimble Connected Community, or TCC, the Connected Farm. Since you have a cellular connection, you can connect to these services. Trimble InSphere, machine-to-machine transfer, remote field support, email from the field. So there's a lot of things to think about since you're using that cellular connection with VRS to give you other services. With that, I want to thank everybody for attending. We do have some questions. We'll go through those now. I'm going to bring up the website here, MidStatesVRS.com. You can go to this website and get more information. You can see they have some FAQs. You can register for today's webinar, but it'll probably be a little late. It's subscription based, so you can register to purchase a user license. Get information about how the anticipated coverage area is progressing. If you have more questions that maybe you think of after the webinar or we don't get to because of time, we welcome you to come in here and put in your question, submit a question. To register for service, you can click here. So So with that, I think what we'll do, Alan, if you don't mind, I may ask you to help me with some of these questions. There's
Yeah,
quite
sure.
a few. Holy cow. So we'll do our best to get through them as many as possible. Like I said, we wanted to cap this off at 45 minutes. So if not, make sure you ask the question. I guarantee you we will answer it directly with you if we can't get to it in the webinar. Okay, well, when will Western South Dakota be included in the network? And I would assume, just knowing this person's asking, Rapid City area, let's just say. I don't know the answer to that question. I don't know if it's on the horizon or if it's something that's being looked at. Alan, do you have any thoughts on that?
Yeah, it's, as you alluded to earlier, Stephen, in the presentation, the expansion of the network is always on the horizon, and basically what it's going to come down to is users, you know. And so if we have a lot of interest in that area for the service, then of course the service would be, you know, brought to that point to serve that user base.
I'll make a point, a couple of points on that. You can see there's, if we're talking Rapid City area, you can actually cover an area like this without connecting to the rest of the network. So you could actually expand here in Rapid City if there's a lot of interest, and then connect back out. That's possible with this system. And I would also encourage, if you are in the Rapid City area, you can see it's not covered today. Come on to MidStatesVRS.com and submit your interest so we can gauge the interest in that particular area. Does that seem fair to say, Alan?
Yes, good point. Use our website to get in and get information and get signed up.
The next question is pretty much the same. Are there plans to extend the network into the missing areas? And certainly there are. We felt like, or I should say MidStates felt like this was the area of interest to start with, and we'll progress it, as Alan alluded to, as there seems to be more and more interest. Okay, can you address the differences between VRS and RTX correction services? Okay, so I will do the best I can. I'm not as familiar with RTX, but VRS correction services are cellular based. You're getting your corrections over cellular. RTX is a satellite based correction. So you need to be able to see the geostationary satellite to get that correction service. That correction service accuracy, Alan, you probably know better than I do. What do they state for that?
Trimble says that it's 1.5 inches pass-to-pass accuracy horizontal.
Okay, so slightly better with VRS. We're saying sub-inch horizontal. RTX
Correct.
is 1.5 inches. So those would be your differences. They're both subscription-based, however. If this says 96 reference stations operational, is this being used by surveyors yet? It is not being used by surveyors yet because it hasn't been introduced to the public until today. We did have some people test in different areas. So as far as testing is concerned, yes. But as far as operational day-to-day, not yet, because it is just being introduced today. What happens to the network, what happens to the network if we lose data connection to the server that sends the correction? So hopefully I'm answering this right. If you lose your cellular service, you're in the field, you go down in a hole, and you lose cellular service, you will not get correction. It'll say radio link down or whatever your indicator is on your particular device. Very similar to using a base station, a regular base station, and radio. It doesn't put the network down. It only does not provide corrections to you as a user. So hopefully I answered that right. How far south of Sioux Falls will you be able to go? So right now, the networks extend south of Sioux Falls to what, Yankton, roughly?
Yeah, we'd be just north of Sioux City.
just north of Sioux City. So I would say that's as far south of Sioux Falls as you can go. I will ask this question because it will come up at some point. You know, can you survey outside or measure outside the network? And you can. We suggest you to be in the network because that's where the error model is being, for the corrections are being calculated from. Once you get outside the network, you need to be very close to the network boundary to get the precision that you're looking for. The farther you get outside the network, let's say 10 miles, the worse the precision will be based on a part per million error. So we don't suggest you to work outside the network unless you absolutely have to, but you can at very, very short distances outside the footprint of the network.
And Steve, I need to correct myself there. When you asked how far south is Sioux Falls, I said Sioux City, and it's actually Elk Point would be our southern
Elk
portion.
Point. Okay, so that's the southern easternmost tip of South Dakota. So Elk Point, South Dakota.
Yes, correct.
Would be a handout for the base locations with a map reference. There is a handout. There isn't specifically a map reference per se, just an anticipated coverage map like we're showing on the screen right now. Because of the system continually being enhanced. So I would say at this point there is not one. But there is a handout with FAQs and a rough coverage map. If you need something very specific, just get in touch with MidStates here, and they should be able to provide something for you. Is it correct that this will only work where you can get cellular data connection? And that is correct. Where you do not have cellular, you will not be able to use the system today. With more base stations, will you be able to get tighter to structures and trees? I would say that that's probably not an indication of being able to get tighter to trees or coverage. The rover is going to react and act just the same as if it was connected to a single reference station. I wouldn't say that because we have more base station, it's going to provide positions that are in areas that I would call not GPS friendly. It's not going to help for that. Any plans to cover Southwest North Dakota? Yes, we talked about that for sure. Satellites at rover, how many do you need, if any? That's the same as a single reference station. So the number of satellites at the rover would be 5 satellites to get a overdetermined solution. So 5 satellites essentially. As long as you can see 5 satellites and you can dial into the server, you'll get a connection and a correction. How serious is intermittent cell service to my signal? It's not serious at all in the respect that you're just going to get radio link down, radio link up, or messages on your device indicating that the cellular service is going in or out. There are different ways. So we've been working with VRS, say, in Minnesota for quite a long time. There are different ways to boost signal, get better signal, things like that. So that is definitely something that can happen. But as far as intermittent service of your signal, it's going to be just like getting intermittent radio connection with your tower or your base station. I've experienced poor cellular in the northwest part of the state, so we don't cover this northwest, so I'm assuming North Dakota. Aware of the schedule for anybody aware of the schedule for additional cell coverage in this part of the state? I'm just going to put it out there because I'm not familiar. I know Nathan Kupfer's on the call. I don't know if Nate, if you've heard anything, you can add to it, or Alan or anyone, but I haven't heard of anything.
I do not hear anything on the Verizon side, but it is getting better as time goes on up there in the Bakken.
Don't understand that. Right.
Yeah, and I would go ahead, Nate.
Can you guys hear me?
Yeah, I can hear you fine.
Yeah, so on the Verizon website, if you go to their website, you should be able to see their coverage now. And I believe they do have a map that shows their future coverage for the full state, or states that you're looking at.
And just to add to what Nathan is referring to, one big contributing factor in success of signal or the ability to use the service is going to be the difference between 3G and 4G. So if you have the opportunity to use 4G modems or an LTE service, you'll have much better coverage in the Dakotas than you will with 3G.
And I'll make one note about all of this that we're talking about cellular service. This is not voice service. Don't get confused with this being voice service. So you go to your Verizon or AT&T or wherever you use and say, hey, can I get a coverage map? And they give you a voice coverage map. This is data service. So data service like a smartphone where you receive emails on your phone, things like that. This is data service. You need to have data service to get a correction, okay? So if you have cell coverage for making calls, but it's kind of poor, you can possibly still send data like a text or check the weather. And those, if you're testing your area, say for instance, those are good ways to test and see if you have data service. Even though the voice service may be poor, and that goes back to Alan's point of 4G LTE service being better if you have that type of device. Okay, this is a good question. Within an individual firm office, to confirm, we will need a subscription license for each individual crew working simultaneously, and that would be correct, yes. So if you have 2 offices and 4 crews, and they all want to work at the same time on VRS, you would need 4 licenses. Not 2 and not 1, you would need 4 subscriptions. So that answers the next question. Can one subscription be used for multiple rovers? They can if they are not working simultaneously. If they need to work simultaneously, then you need a subscription for both. Is this webinar recorded and available for download? Yes, I should have mentioned that as well, sorry. I did have it in my notes, but I didn't. This is being recorded, and it will be available on this website, MidStates VRS. I would look for it probably early to mid next week. We have to convert it and upload it, so it takes a little bit of time, but it will be recorded and uploaded to MidStatesVRS.com. Can you work out of the network perimeter? Yes, again, but just would caution you in doing that. The farther you get away, the worse the precisions are going to be. How do you know if you're inside or outside the network? Again, you want to take the parameters of the network that's being provided here and shown in our webinar as your boundaries as things change. I don't know if there is a connection where they can see the sensor map. Alan, you would have to answer that. I don't know.
No, today we don't have the sensor map displayed.
Okay.
Could be something in the future. Stay tuned. The website changes every day.
Can you shoot under bridges and close to structures? Under bridges, no. Close to structures, if you have satellite coverage and your precision values are low, just like any other RTK or high accuracy mapping product, you can shoot by structures, but you want to pay attention to your precisions. It's no different than using a regular base. Will users be notified of outages? Yes, users will be in a database. Any scheduled planned service that are typically done on the weekends in the middle of the night will be sent out to all users. An outage, unexpected outage, things like that certainly are sent to all users of the system, absolutely. No mention of cost. Can you address this for the mapping application? The mapping application cost is $750 per year per subscription. $750 per year per subscription. The high precision cost is $1,650 per year per subscription. So that's $1,650 for high precision, $750 for mapping. And that is an annual cost. Cost per rover, how much is subscription? I answered that. How come you don't show Williston on the MidStates homepage? It is covered. They're just trying to give you points of reference, but it is covered. It's just not, it just doesn't have a tick on it. It's just this is just for a view so you can kind of roughly see where things are at. But Williston is right in the middle here, so it's certainly covered.
And the locations that are called out on the MidStates VRS homepage map are actually Butler Machinery facilities. Those aren't necessarily receiver positions. They could be, but they're referenced to our facilities today.
Oh, okay. Good point. How far can you work radius from Williston? Again, as long as you're in the network, you can work 50 miles from Williston, as long as it's in the network. There is no radius. You have to be in the network. Some questions about subscription costs. Are you working with DOTs for use with DOT projects? Again, this is just being introduced today, so currently there's no call out for a DOT project to be using this service at this time. With regard to high precision surveying, staking, what is the response time for taking a shot as compared to traditional base setup? That's a good question. How do the speeds compare? They are exactly the same. There's no difference. Once you get logged in, which takes about the same amount of time as getting your base data correction when you start a survey, there's really virtually no difference. And you measure points. The measuring of points and staking and all that, the response time is exactly the same as traditional base. You will not see a difference. Does MidStates VRS interact with Minnesota's VRS? Not at this time. What happens if overlapping coverage areas? Well, that just depends on what you want to use. If you're in an overlapping coverage area, you can have a style or a setting or setup, however it's set up on your particular device, to connect to either MidStates VRS, and you can have a separate one to do the same thing for Minnesota. It would be basically just two, we call them survey styles on the survey side. There would be similar type of setups on the ag mapping or the construction side. Does the southern coverage stop at I-94 near Dickinson? Currently, today it does, yes. So in the southwest part of North Dakota, the coverage stops today, roughly, if you draw a line from Beach, Dickinson over to Bismarck. It's roughly there. Just a couple more. I'm trying to get as many as possible, so I apologize if I'm going fast here. In case you lose network and connections to VRS, you may go to the post-processing mode and continue survey. No stakeout though. It is a good idea to collect GNS rover data during VRS survey anyway. That's just a point, yes, I would say you're correct. So in areas where you lose coverage, you can still work in a post-process scenario, keeping in mind that you have base stations now that are extremely close to you, so high precision is relatively easy to do. KMZ file for the base put into Google Earth to help planning surveys? I don't know. If there's a KMZ file of the base station location so they can see a coverage map, I don't know.
Today we don't have anything that we're going to publish on the website, but as I said, stay tuned to the website for changes and contact us for any further information.
How far from the coverage area is still accurate? Two times 5 miles, 10 miles, or excuse me, 2 miles, 5 miles, 10 miles. As long as you're within the network, the accuracy is, depending on the service you're being provided, is either centimeter or sub-inch if you're doing ag mapping. So as long as you're in the network, it's not, again, relative to how far you are away from the station in Minot. As long as you're in the network, you're going to get the same accuracies as if you were using traditional RTK or if you're using a tower-based service, depending on the service that you subscribe to. How do you do infill and post-process? Again, that was just mentioned. That is not done within the VRS survey. You do have to end the survey, but you could have a survey style to go right into post-process mode, no different than what you do right now with traditional RTK. Will this work with less than 4G service? Yes, you can use 3G. When would the basis be available for processing Opus? If you go look at the NGS website, you'll see that there's a handful of bases already that are available for Opus. They're on the NGS website, and you'll see that MidStates VRS is the owner of those base stations. They're scattered throughout North and South Dakota. They're already up there. So just check out the NGS website if you're interested in seeing where those bases are. see. What is the common coordinate system? That would be the NAT83 2011 reference frame, EPIC 2010. FYI, 12 new Verizon towers going up this year in northwestern North Dakota. Thank you for that, Blake. That's awesome. Would a surveyor need a cell phone strictly for VRS? No, you don't. That's actually a good question. I do want to answer that. You don't need a cell phone strictly for VRS. You can use a cell phone that has data service that can link to the device, controller, machine, whatever you're using. Just note that if you get a call, it could interrupt your correction services. So you can do it. The answer would be no, but it is a little bit more convenient if it is a dedicated device. We've been suggesting for years in some of our states where we use VRS to use a MiFi type of device. It's fairly inexpensive. You can go to, say, Verizon and sign a 2-year contract and get them for virtually nothing. And the cost per month is relatively inexpensive for data. And you would think that you're going to use a ton of data when you're connected to this system, but honestly, you're not going to use a lot of data. A 4 gig plan would be plenty, even if you're working more than 40 hours a week in the system. Yep, comment about coverage in the Black Hills would be great. That's awesome. Pricing, will a repeater radio boost the signal? So yes, you can get like cell phone repeaters or cell phone high gain antennas. If you remember the picture of the cabinet, you saw the 2 big antennas coming out of that cradle point modem to boost the signal. So you certainly can. Again, the cost, repeat the cost, is $750 a year for ag mapping, $1650 a year for high precision. The data files are available right now for post-processing. Yes, that is on the NGS website, yes. For an ag customer who wants to do water management and ag mapping, will we need to have 2 subscriptions? So again, the answer to that would be no. You would just need 1 subscription per device that you want to do mapping with. If you have 2 devices that you're doing mapping with and you want to run them simultaneously, then you would need 2 subscriptions. Do you work on a specific coordinate system, or will this provide any lat long? All the corrections, just like any traditional correction source, whether it's RTX, whether it's a base station, provides those corrections in lat long and height. So you can work in any coordinate system. Do you know when this will be operational? Oh, that's a good question. You can sign up and register today. It takes about 3 to 5 days, right, Alan? 3
to 5 business days for service. That's correct.
Okay, and you can sign up and operate today. I'll not operate today. Operate 3 to 5 business days from today.
The website is operational today to sign up for service. And in 3 to 5 days, you'll have a subscription, or less. We'll get it to you as quick as we can.
So just coordinate systems in the future, like Minnesota County coordinate systems, that's not a part of this system, so I doubt it. You're going to operate similarly to what you do right now, using, at least in North Dakota, using a combined scale factor, converting those state planes to ground. Are you going to allow single base corrections? No, they will only be network corrections. That's the last question, by the way. Again, if you have more questions, concerns, comments, whatever, we welcome you to go to the website, MidStatesVRS.com, put in your information and submit your request, and we'll do our best to answer it. I do appreciate everybody attending. We are 10 minutes over, but you know, it's great that everybody was able to attend. We had a huge turnout, and I do appreciate it. Thanks, Alan and the others at Butler. And Nathan for their assistance, and again, have a good Remembrance September 11th day, and again, we thank you for attending today's webinar.
Thank you, Steve, to your group and to everyone attended today.